Mute the bridge, please.
The conference has been unmuted.
Okay, one more opportunity to use the audio bridge for questions. Okay, we have one question already showing up in the box here. Banner is equivalent to QS flow. Absolutely correct. That is like one QS flow. Yes, that is correct. Okay, any other question?
Follow up on the dual stack concept. I understand what you explained, but I've also heard in some circumstances where they talk about maybe the network, the transport doesn't support V6, but the end devices do, so they do like V6 protocol over V4 transport or vice versa.
Oh, I see. Yeah, correct.
And that's different than dual stack, right?
That is different from dual stack. Yes, dual stack purely means that the device, in our case, let's say the user equipment, supports both IPv4 and IPv6 at the same time. Now, the other thing that you heard that we can transport IPv4 over IPv6 or IPv6 or IPv4, that doesn't matter. So let's say, let me draw a picture. Okay? Let's say my device supports IPv6 only. Okay? And here is our PGW. Okay. But now we need to pass through some network. Here is the web server. But that web server supports IPv4. Okay. Or maybe, yeah, let's do this way. This would be more accurate. Let's say I have IPv4 network. And this is IPv6 web server. That is more appropriate because we have end-to-end IPv6 between the device and the server. However, it has to pass through the IPv4 network. There is no IPv6. So in that case, we will have this IPv4 packet that will be processed by all the routers inside this network, and inside that we will put the original IPv6 packet. Now, this specific would be the scenario that will last for several years, right? Because today, most of the networks are supporting IPv4, and only some networks support IPv6. So until we have upgraded everything to IPv6, right, then this kind of scenario will last for a long time. Another example may be what you will. Okay, so this is if. Okay, so this is if UE supports IPv6. Okay, but I will give you more prevalent scenario. This is most likely to happen. Most likely in initial LT deployments. Okay, so my guess is that AT&T, Verizon Wireless, right, they would probably use IPv4 for the UE, and they will use IPv6 because this is okay. Let's talk about Verizon. Most of you have 1xMDO background, so probably Verizon is of more interest to you. So IPv6 within the network. And the reason I'm saying that is this is mandatory for DO-LTE interworking. Because the standard is using proxy mobile IP version 6 IPv6. Okay, PMIPv6. So we will have, let's say, if this is DO system that has been upgraded, so now it is eHRPD, and one of the gateways is your HRPD serving gateway, So think of this like a PDSN or foreign agent, and that connects to the PGW. This is LT, and here is our PGW. So between the HRPD serving in PGW, we have mobile IP tuner, but that is IPv6. So when we are in the DO coverage area, let's say this is IPv4 UE. Now the IPv4 packet goes all the way to the serving gateway, and then we will have IPv6 packets. But inside the IPv6 packet, we will put in the original IPv4 packet for the use. So this would be more likely the scenario that we have. And once we connect to the internet, and since most of the internet today is primarily IPv4 web server, then here we'll have the regular IPv4 connectivity for this IPv4 packet. So this would be the most common scenario for several years initially. Eventually we want to move toward IPv6, but we have already invested quite a bit into IPv4, so IPv6 is getting delayed for that reason, primarily that reason. But thanks for your question. Any other thoughts or comments?
So just to follow up on that, so then either IPv4 encapsulation in IPv6 or IPv6 encapsulation in IPv4 is possible. It basically just depends on the protocol supported at the endpoints versus the protocol supported in the transport now. Right?
Exactly right. Exactly right. So here, in both the cases, right, our UE just supported one IP type, right? So there was no dual stack from the UE's perspective in these cases, in these two cases. Okay, any other follow-up questions or any new questions?
Can you send us the messaging between the UE and the network from total authentication to end to the SCW?
SCW. Okay. So you are saying that can we?
No, I just want to look at the messaging. Not now. Just talking about we don't get the messaging or how the call is established. I just want to see from end to end what the messaging is from a UE down to the network.
Oh, I see. So
yeah.
Okay.
When you send your back, I just want to see what the messaging really looks like from end to end.
Okay, sure.
Yeah.
Okay, so we'll try to do that toward the end. Okay.
Right.
Okay, sure. Okay.
I have another question on a different topic.
Sure.
On the DHCP, why would it seems like in your description there that the UE is making the decision to use DHCP, is that correct?
Yeah. So the UE initially mentioned in the protocol configuration option, PCO, that it would like to use DHCP approach. So in that case, the network says, okay, I will not give you the IP address during the default bearer activation, but I will let you get your own IP address using DHCP. That is correct.
Okay, so that indication would be part of the initial request from the UE, and then the network would know not to assign an IP address during the cache procedure, you're saying?
Yes, absolutely correct.
Thank you.
Sure.
Can you? Okay, so I guess the follow-up though is why? Is there an obvious reason why the UE would want to use DHCP instead?
Oh yeah, because see some devices, right? They support DHCP. So they want to get the IP address using DHCP. That's it. No other specific reason. Yeah, they just have implemented the DHCP stack, so that's why they would like to do that. But from the network's perspective, it doesn't really matter because our PGW will just pretend that it is the DHCP server, and then it will just give the IP address. Because this UE understands simple IP. Okay. Why do we have DHCP? Because that UE supports simple IP. So, for example, I have heard these Microsoft applications. They understand DHCP, simple IP. Okay, not the traditional mobile IP, the foreign agent type stuff. They do not understand. They understand simple IP. So they are able to construct the DHCP messages. So from the US perspective, it thinks that, oh, I'm using DHCP, right? So we can do that, but we can take care of the mobile IP aspects within the network by using proxy mobile IP. And that is the trend, that we are moving from client-based mobile IP of 1xc video to proxy mobile IP. But the only reason is that most devices, I do not know about most, but many devices support just the DHCP. That's the way they get IP address. Okay. Any other thoughts or comments? Any questions? New or follow-up questions? Okay. Okay. So let me give it 30 more seconds. No questions.
Yeah, I do have one more question.
Okay.
I apologize if I missed it, but in the attach or in the procedures that you went through, you talked about setting up the default bearer.
Correct.
But then there was also discussion of multiple bearers.
Yeah.
Is that done subsequently then?
Yes, subsequently. Correct.
Okay, and the UE would trigger that based on its capability to send different types of bearer services, or what?
Okay. Good question. Very good question. Okay, so first, let's be clear. There is only one default bearer. So as part of the default bearer activation or as part of the initial attach, we just establish default bearer, only one bearer. Okay. And subsequently, as you correctly guessed, we can establish additional bearers, and they are called dedicated bearers. Okay? And the reason that we want new dedicated bearers is we want different QoS from what the default can offer us. Default is basically better, no real guarantees of any kind. So anytime you want specific QoS, you need basically dedicated bearer. Now that can be triggered either by the UE or by the network. So it could go either way. Okay. It could go either way. So in a simple case, let's say that on your mobile device, you have some sort of icon for your voice or IP call, or some icon for your video streaming download. So when you click on that icon, then the mobile device will send a request to set up a new dedicated bearer. So in that case, it will be triggered by the mobile device, and sometimes the network can trigger that. So maybe when we click on some icon, then a SIP message will be created, SIP invite message will be created by the mobile device, and that SIP invite message will be processed by some application server, and then the network can trigger the establishment of a dedicated bearer. So it could go either way. Both are supported by the standard.
So other than the QoS parameter that is associated with a dedicated bearer versus a default bearer. What are there any other differences?
No, no differences.
Okay, thanks.
If you never cared about QoS, then default bearer is more than good enough. Okay. Anything else? And we do appreciate your questions. So thank you for asking good questions. Anything else? I will give you 30 more seconds. Okay, very good, very good. So Eric, let's mute the bridge and move on with the presentation.
The conference has been muted.
Okay. So we talked just before the break some characteristics related to the IP address allocation. And now we'll turn our attention to quality of service. The basic idea is the following. Within a bearer, you could have multiple services, multiple service data flows, SDF. And service data flow, maybe this is email, maybe this is web browsing kind of application, etc. As long as you want to give the same QoS treatment to both the service data flows, you can map them onto same bearer. But anytime you need different QoS, in this case voice over IP, then we need another bearer. So in summary, remember that we control the quality of service at the bearer level. We do not separate the data flows within the bearer for quality of service. So for example, we'll say bearer number 2 will have delay less than 100 milliseconds, and we will have guaranteed bit rate of, let's say, 20 kilobits per second. So we are providing the guarantees for that bearer. Okay. So we are not saying anything related to the data flow, right? We control the QoS at the bearer level. So if we have two services here, two service data flows, then we will say that, okay, we will have maximum bit rate of 1 megabits per second, let's say. But now, within that 1 megabits per second, how much for email, how much for web browsing? No distinction. We do not separate them. The total is 1 megabits per second. Maybe 900 kilobits per second for email and only 100 for web browsing. That may happen because we did not guarantee the QoS for SDF. We guaranteed QoS for some bearer. So in summary, always remember that the bearer is the level at which we control quality of service. Okay. Now, to quantify quality of service, we need some sort of parameters. So how do we take care of those? So we have something called QCI, QoS class identifier. Okay. And we also have something called allocation and retention priority. Those are the main parameters that we will use for quality of service. Now, in general, a bearer could be a guaranteed bit rate bearer or non-guaranteed. Guaranteed means there is certain minimum guarantee, maybe 100 kilobits per second minimum rate, something like that. And non-guaranteed bit rate, no guarantee of any specific data rate. Okay. Could be even 0 kilobits per second. But the quality of service, of course, control at the bearer level. Okay. Now let's look at this QCI. In LTE, we have 9 quality of service classes, 9 QCI, 1 through 9 here. So let's pick QCI number 1. So that is guaranteed bit rate type bearer, and it says that voice or IP would be one example of the service that can use QCI equals 1. In that case, we want to control the delay such that it is less than 100 milliseconds. The error rate we can tolerate is 1%, so 0.01, 1% error rate. So out of 100 packets, if we lose one packet, no problem, we can tolerate that. And then associated with QCI, there will be some priority. So here we are giving you various examples for your information. So you can look up here. Basically 9 QoS, they have different packet delays, different error rates, and different priority. Okay. Normally, if you go to the web browsing or email kind of applications, they will have basically lower priority. Okay, because we are not trying to have very, very tight control of delay. Even if 300 milliseconds delay, we have no problem. Right? As long as we can download the web page reasonably fast, we do not worry too much. We do not complain about that. But for voice, yes, we have to have tight control over the quality of service. So these are the examples of the QCIs that are defined in the standard. This is from the standard. If you want more information, here is the document for you. Okay. But in summary, we have 9 QoS classes. So whatever service you want to offer, you will have to map that service onto one of the 9 classes, and then we can say that, oh, I want to have an EPS bearer with QCI number, let's say 2, and that will correspond to certain performance metrics as highlighted here. Okay. So that would be how we can make a request, and then reserve adequate resources end to end between UE and the PGW so that we can meet the QoS requirements. Now we have a whole new architecture called PCC, Policy and Charging Control. So this architecture often considered part of the IMS, IP Multimedia Subsystem, that will help us implement some policies within our network. So we have 2 main functions. One is how to ensure that users are following the policies. So maybe we have certain maximum data rate requirements. We allow certain types of services and so on. So that's one thing. We are controlling the services and also charging. How to charge the user. Maybe for one kind of services we would charge the user one way, another kind of services another way. So if it's voice or IP call, maybe we would charge maybe 5 cents per minute. That would be one way of charging one kind of service. If it is email or web browsing type services, we say, okay, maybe we will charge maybe $2 for 10 megabytes of data transfer, something like that. So we can charge the user based on the services. Okay, so that's where the PCC comes into the picture. Now, how do we know what kind of QoS is required? That's where this application function comes into the picture. So normally what would happen is, let me draw a picture. Let's say there is some specific service, maybe some video streaming or something like that, some special service, and our user equipment has some icon for this service. So when we click on that icon, then a SIP session initiation protocol invite message will be sent. Eventually that will reach the application function. Okay, that is responsible for this video streaming application. Any kind of, I'm just giving one example, but it could be any kind of service. And inside that we have the required QoS. So there is something called STP, Session Description Protocol. So it would indicate what kind of quality of service we need, some sort of data rate requirement, maybe even some codecs that we can use, voice, video, or whatever. Okay, so things like that. So application function now knows about the required quality of service for that specific service at that time. So application function, which is formally part of the IMS network, will then forward that to the PCRF, policy and charging rules function. So now the PCRF will then consult the subscription profile repository, SPR. So this could be just part of the HSS also. These are all logical components. So you can physically put them in some box, okay, but maybe this is part of HSS. In any case, this is what the user has subscribed to. And so PCR will make sure that, okay, this user can receive this kind of quality of service, this kind of data rate and so on. And then it will tell the policy and charging enforcement function. This is your PGW. So PGW enforces the policy. So it will tell, okay, do not allow more than 10 megabits per second. So we have these kind of policies conveyed to the PCEF. So PGW can then make sure that we do not exceed that data rate, or we allow that kind of service flow to pass through the PGW. So that's one kind of thing. Also, we can decide how to charge the user, what kind of service we have. So accordingly, we will say, okay, PCEF can consult this offline charging system. So this is where we get monthly bill. Right? That, oh, this user during this month downloaded 10 gigabytes of data. Okay, because the packets will always travel through PGW. So PGW can provide that information to some charging system, and then based on the rules, we will create a bill for the user. Okay. So we talked about this, and there could be online charging. So think of this like prepaid. So maybe we have $100 in our account, and whatever that $100 right allow us to do, maybe we can talk for 1,000 minutes or whatever, something like that. We need to make sure that we do not exceed that. Right? So based on our charging rules, we should not allow the user to spend more than $100. Okay, so that's the credit control there. So we talked about that. There is this function called bearer binding event reporting. So if we are roaming into some area, so if we are Verizon subscriber, we roam into AT&T network, then this function will tell the PCRF that, oh, this user is right now roaming. And now if we have not subscribed to roaming services, then PCRF will say, oh, we cannot allow this user to access services because this user did not subscribe to roaming service. So that's one way we can control access to the service. Okay. Now, there is one sort of important piece of information, but there is no suitable place for that. So we are just mentioning here. Now, when we say we have bearer, we are trying to meet some QoS at the bearer level. And let's say this user has subscribed to the service, maybe platinum services. So we should allow the user maybe 200 megabits per second maximum rate. Now the question is, how much can that user equipment handle? Even though it's a platinum subscriber, maybe the UE does not have physical capabilities to support that kind of high rate. So that's where these capabilities come into the picture. So at some point during the bearer setup, we should figure out the actual capabilities of the user equipment. Okay? So the A node B can make a request to the UE that, okay, tell me your capabilities. So UE capability inquiry message will go to the UE. It says, give me your EU trap, that is LTE, Universal Terrestrial Radio Access. Give me LTE capability. In response, the UE will provide the categories. So I will tell you some additional information just in the next few seconds, but let's say this UE says I'm category number 5. So now our E node B knows what this UE is capable of. So when it is trying to implement some QoS, then it knows what it can really offer to the user. Okay? And we can provide the capabilities to the MME also, so MME can keep a record of that. Now, here are the capabilities of the UEs. There are 5 categories of the UEs defined. In the top portion here, we are giving you the downlink related information. So for the downlink, we have up to 300 megabits per second data. So only category number 5 can support 300 megabits per second. All the other categories, they are lower data. Okay. So only the category number 5, the super duper category, only that category is able to give us 300 megabits per second. And only category 5 can support 4 antenna transmission. So basically, for E node B has these 4 transmit antennas, and the UE can handle all those antenna transmission because it has 4 receive antennas. 4 receive antennas. Okay. So all the other UEs, they are lower capability UEs. Okay. So they cannot support this kind of 4 antenna transmissions. Only category 5 can do that. If you are thinking about the uplink, category 5 will give you 75 megabits per second. And only category 5 can support 64 com in the uplink. All the other will support 16 com, not 64 as the highest order modulation. So basically, in summary, we have 5 categories of UEs defined for LTE, and category number 5 is the super duper category that can support as high as 300 megabits per second downlink, 75 in the uplink. There is only one default bearer. However, anytime you want new QoS, you need a different bearer, and that is called dedicated bearer. So in this example, we have network initiated dedicated bearer established. So this application function, which is part of this IMS network, has decided that, oh, we need to have a dedicated bearer for this video streaming type application. Okay. So then we are sending the request for the bearer establishment to the PGW. PGW may apply some local policies, okay, or it may say, okay, I'm fine with the QoS request that we have as part of the SDP, and it will send this message: create dedicated bearer. Okay. The reason there is dedicated because we have specific QoS, different from the default bearer QoS. Okay. And now the MME will receive the message, default bearer, dedicated bearer request message. It will contact the E node B. Do you have adequate resources to support this quality of service? Node B says, okay, I have enough resources, so let me reconfigure the RFC connection And now we will tell the UE that, okay, you can expect to have another radio bearer with certain quality of service. So we set up the radio bearer, and then we have to establish the S1 bearer, we have to establish S5 bearer, so that we can also provide the QoS within the network itself. Finally, we'll contact the PCRF that, okay, we have taken care of the QoS for that UE at that time. Okay, so let's do some questions, and then we will answer some questions that have appeared in the questions box. So let me give you maybe 2 minutes for this one. And please participate in the poll. At least this should be easy, 50% chance of getting this right. But if you have been paying attention, should be close to 100%. But there is no fuzzy logic here, binary logic, true or false. No penalty for a wrong answer. So if you have to guess, I hope that you do not have to guess. But in case you have to guess, please do so. But we really need your participation. So please participate in the poll. Very easy. Think and click. Yeah, I can click, but thinking is the hard part, isn't it? Thirty seconds. Okay. The QoS is supported at the bearer level. That is correct. Anytime you want specific QoS, you need EPS bearer. So always remember that the QoS is controlled, is enforced at the EPS bearer level. One more question. I will give you a minute and a half. Which is that category that can give us the best possible performance that LTE promises? And LTE promises a lot. 300 megabits per second, downlink 75 uplink. Let me make it interesting. We have only up to 5 categories. Maximum of 5 categories are defined. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are the only 5 categories. There is no category 6, no category 10. And I suddenly got 100% accuracy. So we went from about 80 or 90 to 100%. See, my hint does work sometimes. Okay. Very good. So category 5, that's our category. Okay. So let's answer some questions here. Can the UE have different downlink and uplink performance? Oh, no. Actually, a given category, let's say here. Okay. So once you pick a category, category 2, let's say. So then that category 2 means you will always have up to 50 megabits per second for the downlink. You can support 2 antenna transmissions. So we have 2 receive antennas at the user equipment. And that category 2, what can it do in the uplink? Well, it can support 25 megabits per second. And of course, it does not support 64 core. So you have one of these 5 categories, and that's what will dictate your performance. Okay. So you cannot have different categories for uplink and downlink. Okay. Okay. Now we had one question on summarizing the end-to-end flow. So let me try to do that, and then we'll see if that question is answered or not. So let's go to the end-to-end view. Okay. Okay. Okay, so we will consider default bearer activation, end-to-end flow. Okay, now we should keep one thing in mind, that as far as the UE and the E node B are concerned, they will just rely upon the RRC signaling. So even when we want to send non-access datum signaling, meaning related to the core network, even that will be part of some RRC message. So this is some RRC message, and inside that we will put this non-access datum message. Okay. So as far as the air interface is concerned, we still rely upon the RRC signal. Okay. So let's take care of that. Okay. So before, okay, so after power on, we need to do, actually initial attach. Let's call it initial attach. The default bearer activation is just part of that. So main focus is on initial attach. That will give us end-to-end flow. Okay, so we here need to do attach operation. So for that we have some prerequisites. So basically we need to do synchronization and network acquisition. So basically our UE will just observe to carry that out. Just observe downlink of the strongest set. It does not need to exchange any messages. Just observe the strongest set. And it will use the help of primary and secondary synchronization signals. And that way it will know the cell ID, physical cell ID. Then it will use the help of the broadcast channel. It will get master information block that contains system bandwidth and so on. So we are not exchanging any message, just observing the downlink. That's it. Okay. Now the message exchange. Okay. So the UE has to first establish RRC connection. So connection establishment, and RRC is just between the UE and E node B. That's it. It will end there. Okay. Then once that is done, we can send attach request message, because we are trying to do the attach operation. Okay. So we have attach request. But that attach request is a non-access threader message. So we will have RRC connection setup complete message going from UE to the E node B, but inside that we will put this attach request message. Okay. Okay. Now, as part of that, it made a request for some sort of IP address, right? That I need an IP address, for example. Okay. IPv4 type IP address. So as far as the UE is concerned, the only message it will get now in response to that is RRC reconfiguration message. And as part of that, it will get attach accept. So from the UE's perspective, if you are looking for layer 3 signaling, okay, you have these two main messages. Okay, and behind the scenes, within the network, a lot of things are happening. Right? So within the network, okay, MME, for example, is now getting this attach request message. So it has to do the authentication now. So authentication. But again, that will be, so let me use the same so authentication request, but that is again non-access status. So as far as the RRC is concerned, okay, this is RRC reconfiguration. As far as the RRC is concerned, this would be downlink information transfer. And when the UE responds, let me create some space here. Okay. Okay, so when the UE gets this downlink information transfer, it will respond with authentication response, again non-access status. So this red is non-access status. But as far as the RRC is concerned, this message is now uplink information transfer. Okay, so that is our, this would basically contain the response, okay, to the authentication challenge. This had the random number and authentication token, so we know about that. And finally, once the MME is happy with the authentication, so authentication successful, then it will go ahead with the default bearer activation. So then lot of things are happening within the network. So MME and SDW and PGW and the MME versus E node B, right? Lot of things are happening. But as far as the user is concerned, finally, we will send this message, RRC reconfiguration message, and inside that we have attach accept message, and we have taken care of the default bearer. We have taken care of IP address, okay, and so on. So that final step, let me show you in the presentation file where that final step is. So let's say IP address. This is that final step. Okay, so we sent the attach accept message. Let me highlight this as part of the radio resource control connection reconfiguration. There's a attach accept. Now, as part of that, we are giving the bearer that we established, right? And we are giving the user IP address, which is here PDN address. That is the IP address for the user. And the user just sends the acknowledgement messages, RC connection reconfiguration complete, because that it has to send in this one to the reconfiguration message. And we have to tell the MME, right, that we have received your attach accept message. So attach complete is sent. But this is a non-access status message. So whenever you want to send a non-access status, you have to use the uplink information transfer. That is the name of the RRC message. So this way we have taken care of the bearer. So let's unmute the bridge, please. Eric, shall we unmute the bridge? Okay, let me try.
The conference has been muted. The conference has been unmuted.
Okay, so is this adequate? Because some student had this question, end-to-end signaling between you and the network. So is this what you wanted or something else? Okay, so if there is no negative acknowledgement, I will assume that you got your okay, and if you are not
The conference has been muted.
okay, so looks like now we are okay. Okay, very good. Now, what kind of QoS does a default bearer support? See, even though it is up to the operator, I tend to think that it would be like QCI 9 or so, because we do not want to guarantee any specific data rate. Whenever the E node B has resources, it will allocate those resources. Okay. And delay also, right? We want to have flexibility. So, in my opinion, it would be along the line of QCI 9. Okay, so that's what we had planned for today. Okay, so let's summarize some of the main aspects. Okay, so once we power on the UE, it will synchronize with the network. It will perform the network attach operation. During the synchronization, we need to have timing and frequency synchronization, and we will use the help of primary and secondary synchronization signals for timing and frequency synchronization. Then we will use the help of broadcast channel, and we will also observe SIPs coming on the physical downing shut channel, and that's how we learn about the system. To carry out initial attach, the UE will send attach request after setting up the RRC connection, and once the MME receives the attach request message, it will authenticate the UE. And of course, we have mutual authentication. Okay. So the UE authenticates the network, network authenticates the UE. We can allocate the IP address as part of the default bearer activation or after establishing the default bearer. Okay. These are the two basic ways. And quite flexible. We can give IPv4 or IPv6 or maybe both the IPv4 and IPv6 addresses to the user. IP address can be static, can be dynamic. Okay. Very, very flexible. Okay, default bearer. We want to basically provide always on experience to the user. So even though there are no guarantees of any specific data rates, at least we can take care of the basic services such as email. But anytime you want to provide quality of service, tight quality of service, you need dedicated bearer. So default bearer, basic services, let's say best effort type services, but voice over IP and streaming, wherever you need stringent QoS control, you need dedicated bearers. Different categories exist. In category number 5, that supports the best possible performance available with LT. So we thank you for your questions and thank you for answering my questions. We will unmute the bridge at this time to see if you have any additional questions. I will stay here as long as you have questions. But Eric, shall we send evaluation toward the students?
The conference has been unmuted.
Okay, the bridge is now open.
Okay, and if you do not have a question, *6 to mute. *7 unmute. Okay, if you do not have a mute button on your phone. But of course, for questions, please unmute your phones and feel free to ask questions. Any questions?
Oh, yes, I have one question.
Yes.
Between RRC configuration and RRC configuration complete, there is a uplink. UE sends some uplink.
Uplink information transfer, yes.
What is that?
Oh, okay. Yeah, see, here is one problem, not the problem, but there's the way the standard difference. When we send this RRC reconfiguration complete message, since there are no evaluations here, I can even go to that slide. So give me a few seconds.
RRC configuration with attach access.
Yeah. So,
and then there is a uplink,
uplink information. The situation is that as long as I remember, RRC connection reconfiguration complete, this message, there is no NAS message capability. So inside the RRC connection reconfiguration complete, we cannot send a NAS message. Here, this one. So if you want to send a NAS message, you need to send an RRC message called uplink information transfer.
This is a NAS message?
Yeah, because this, no, attach complete is NAS message. So attach complete is a NAS message. So whenever we want to send a NAS message, we have this available to us. RRC message called uplink information transfer. And as part of uplink information transfer RRC message, we can send out some NAS message such as attach complete. If we had the capability of sending RRC connection reconfiguration complete with NAS message, then we would have done that. But when I checked the standard, I did not find any NAS information there. So I had to create this uplink information transfer. In general, you have two messages which are available for NAS. Downlink information transfer and uplink information transfer. These two are RRC messages that can carry NAS messages. So anytime you want to send NAS message, you can put those messages inside uplink and downlink information transfer message. So,
And what are the typical information carried in uplink information transfer?
what is the typical information?
Yeah.
Oh, this NAS message would be the typical information. A NAS message such as attach complete, or there may be some other message also. But if you look at the standard, this 36331, right, you will see what fields are available. But I think the primary reason for such message is just for NAS transport.
So this uplink information transfer is sent to ENOB from
Yeah.
and then ENOB would transfer this message.
Yeah, it will extract the NAS message and
to
forward it to
MME?
the MME. That is correct. Yes,
Thank
absolutely correct.
All right, thanks.
Yeah. The reason that I had to do this is I did not find any NAS field in the RRC correction reconfiguration complete. If you look at the other message such as, let's say, where are you? Okay, maybe the initial. Okay, give me just few more seconds. Okay, not here. Attach request. Okay. I am looking for some RRC. Okay, maybe. Oh, where did my RRC connection go? So basically we have, here, this. Okay, so we are trying to establish RRC connection. So if you look at this message, RRC connection setup complete message, so it is RRC message, but we have this field called NAS information. So inside that NAS field, we can put in a message such as attach request. This is a NAS message. But I did not find similar NAS field for RRC connection reconfiguration. That's why I had to use the uplink information transfer. Okay?
Okay. Thank you.
Sure. And thank you for your question. Anything else? So, Eric, shall we send evaluation to the students, please?
Okay, and just a quick reminder for those of you who have not participated in this